on Friday because I'm also taking one course with Kwan Hoja, econometrics course. So he also comes like after every 2 weeks. So he's telling us we have a quiz this Friday. So okay. I hope my screen has been shared. Okay, guys, today I want us to talk about hypothesis testing. Have you done it? You should. You have done it, but maybe you don't know. Hypothesis testing. If you notice, I don't want to write in the board. I'm writing here so that it should show in the record. Now, if you remember very well, I showed you how to interpret coefficients, right? Like if we have the coefficients, how can we interpret it? If it is log regression or log level or level log or level level. So most of the times they usually use log regression models because it's easy to interpret. You just express everything as a percentage. So let's assume we have a model like this: GDP equals beta 0 plus R1 FDI plus error term. Of course, GDP is our dependent variable. FDI is independent variable. We know beta 0. What's beta 0? Constant or intercept, right? What's U? Error term. And what's B1? Beta 1? Yes, it is a coefficient of FDI, or it's also the slope, right? And in this case, it is simple regression because we have just one independent variable. We can have more than one independent variable. Let's say if we have 2 or more independent variables, that will be multiple regression. We have not done it yet. We'll do it next week. We are still with simple regression. So just one independent variable. So I showed you how to interpret coefficients. By the way, guys, let's use log. So I'll put here lin. Let me put here lin. So it should be log transformed. So I showed you how to interpret coefficients. For instance, let's assume that this beta 1, let me put here in bracket. Let's assume that this beta 1 coefficient here, this slope coefficient, let's put any value there. Let's assume it is 5, right? And let's assume that our constant is 3. So, of course, we have to delete error term, right? Once you estimate your coefficients, you should not include error term. Now, how can we interpret these coefficients? Of course, I showed you. Since it is log, we have lin and we have linear. We can express everything as a percentage, right? So what you can say here is that a 1% increase in FDI causes a 5% increase in GDP on average, right? And let me write here. I'm recording so you can watch it. A 1% increase in FDI because GDP to increase by 5% on average. So you have to always put on average. So actually this 5 here is telling you the degree to which independent variable affects dependent variable. And you see we are putting everything in percentage because it is log model, lin. Everything fine, right? Now, here is increase. Why is it increase? Because this coefficient here is positive. If this coefficient here was, let's say, -5, then here would have been decrease, right? But this first guy here will always remain increase. We are interested in knowing what is happening to the second guy, the dependent variable. If the coefficient there is positive, it it is increase. If it is negative, it is decrease. That is how we interpret coefficients. So that's the slope coefficient. Now, let me put back plus. What have I done? So I'll put back here. Increase. Okay, that's the slope. Of course, we can also interpret the constant. This is the constant. In most studies, or most at times, the constant is meaningless. It makes no sense to interpret it. But it doesn't mean we cannot interpret it. We can interpret it. How do we interpret this constant? To interpret this constant, to interpret this constant, the constant is telling us what the average value of the dependent variable will be if the independent variables are eliminated. That is, if we don't consider the effects of the independent variables. Okay, so if I'm to interpret this constant, what I will say here is that without the effect of FDI, the average GDP will be 3%. Does that make sense? So this 3 here is the constant. It is telling you what this GDP will be if we don't consider the effect of FDI. So if you don't consider the effect of the independent variable, then the value of the dependent variable will be equal to that constant. So this constant here is 3. So to interpret it, we'll say without the effect of FDI, the average, again, you have to always mention average. The average GDP will be 3%. We are using percent because it is log. You remember, right? Everything fine. Okay, that is how to interpret coefficients. But now there is a problem. When do we interpret coefficients? We don't interpret coefficients in all cases. Now, this 5 here is the slope. We have interpreted it. Now, before we interpret this 5, we need to make sure it is statistically significant. If it is not statistically significant, we cannot interpret it. In statistics, in econometrics, in finance, we don't interpret insignificant coefficients, right? It must be statistically significant. By statistically significant, I mean it should be statistically different from 0. Of course, mathematically, you know that 5 is different from 0. 5 is not 0, right? So mathematically, it is not 0. But we are not interested in mathematics. We are interested in statistics. So we want to find out if it is statistically equal to 0 or not. So we are going to, that's what hypothesis testing is all about. So we are going to carry out a test for significance. Test for significance. We want to find out if the coefficient is statistically significant or not. And this test we are going to use is t-test. The t-test shows us the statistical significance of individual variables. Now, to carry out this test of significance, we can use the a t statistic, and we can also use the probability value. This t statistic, like in short form, they can call it t stat. Times you see t ratio. I'm just giving you other names. So when you see t stat, t ratio, it is t statistic. This probability value at times in short form they will abbreviate it prop value. In places they will call it p value. It's the same thing, right? So we can use either t statistic or probability value to carry out this t test. And this t test, we are trying to test the statistical significance of coefficients, individual coefficients. Now, in any hypothesis testing, in any test we want to carry out, we need to know the null hypothesis and the alternative hypothesis. If you remember, when we were looking at descriptive statistics, we did the Jagbera test. And the Jagbera test, we saw the null hypothesis and the alternative hypothesis. I even gave it in the assignment. So for this t-test, what's the null hypothesis? Null hypothesis. That is H0. The null hypothesis is that the coefficient is statistically equal to 0. And the alternative hypothesis, that is H1, is that the coefficient is statistically different from 0, right? So once we know the null hypothesis and the alternative hypothesis, we can perform the test using the t-statistics and or the probability value. I'm going to show you how to do that. But before showing you how to do that, I'm going to show you the decision criteria that you should know when we can reject the null and when we cannot reject the null. So decision, oh my God, criteria. So let's say we want to use the t-statistic. How do you spell it? T-statistic, and we're also going to use prob value. Okay. So for the t-statistic, if we are going to use t-statistic to perform this test, then our t-statistic should be greater than the critical value in absolute value, right? That is, the absolute value of the t-statistic should be greater than the critical value. If this happens, then we'll reject the null hypothesis. Otherwise, we cannot reject the null. I'll explain to you what all these things mean. I'm just trying to be fast because there's no time. So if we are using t-statistic to perform the test, in order for us to reject the null hypothesis, the absolute value of the t-statistic should be greater than the critical value. Now, if the absolute value is less than the critical value, then we cannot reject the null. The question you ask me now is, what is this critical value? In order to get this critical value, we need to look at the distribution tables, t-tables, which is, I don't want to get into that. So since we don't have the t-tables with us, we use rule of thumb. Rule of thumb, like, let me spell it. Rule of thumb. So for this t-test, the rule of thumb that we use for critical value here is 2. We say critical value is critical value is 2 according to rule of thumb. Rule of thumb simply means generally accepted rule, right? Now, since we are taking the critical value to be 2, what does it mean? It tells you that if the absolute value of the t-statistic is greater than 2, then we are going to reject the null hypothesis. But if the absolute value is less than 2, then we cannot reject the null hypothesis, right? So take 2 as the critical value. Guys, one other thing I'm going to tell you is that it should not be, it must not be greater than 2 in all cases. So instead of saying greater than 2, we can say it should be around 2. It should be around 2 or greater than 2. Why? Because at times you see a case where maybe it is 1.99. It is not greater than 2, right? 1.99 is not greater than 2. But if you check the probability value, you will discover that it is telling us that we should reject. So at times it can be 1.98, 1.99. It can be closer to 2. So let's say it should be around 2 or greater than 2. But if it is very far from 2, maybe like 1.5 or 1.3 or 0 point something, then that one is less than 2. But if it is around 2 or equal to 2 or greater than 2, then we can reject the null hypothesis. But if it is less than 2, really less than 2, we cannot reject. I will show you an example. So that's how we make the decision using T statistic. Now, if we are to use probability value to make this decision, probability value, then yes. Equal sign where? Equal sign, it's like hyphen. Okay, let me put like this. What I'm telling you is that for us to reject the null, this condition must hold. The absolute value of the T statistic should be around 2 or greater than 2. If it happens that way, then we can reject the null. But if the absolute value of the T statistic is less than 2, really less than 2, then we cannot reject the null. We never accept the null. You just say we cannot reject the null. No. If you accept alternative only if you reject the null. If you reject the null, you accept the alternative. But if you cannot reject the null, then you don't even bother about what is happening to the alternative. You focus only on the null, but you don't say you are accepting the null. No. What you should say is that you cannot reject the null, right? Okay. Fine? Okay, so that is how we can make the decision using T statistic. But if we want to make this decision using probability value, it's even easier, and I like using probability value. We need to consider the level of significance. Of course, I told you we have 3 levels of significance, right? We have 1%, 5%, and 10%. Now, I'm showing you all these 3 levels because you have to know it. But generally, they use 5% in studies, like in most papers in the literature, most theses and whatever, they use 5%. So if you are to focus on one significance level, you should focus on 5%, but know that we have 3 levels of significance. Now, what happens if we are using probability value? For us to reject the null, the probability value should be less than the significance level. Then we reject the null. If probability value is greater than significance level, we cannot reject the null. Okay, guys. Now, if we are using probability value to make this decision, then in order for us to reject the null, this condition must hold. That probability value must be less than the significance level, right? So let's assume that our significance level we are using is 5%. then in order for us to reject the null at 5% level of significance, the probability value must be less than 5%. If we are using 1%, then in order for us to reject the null at 1% level of significance, the probability value must be less than 1%. So in order for you to reject the null at a given significance level, the probability value must be less than that significance level. If the probability value is greater than that significance level, then we cannot reject the null. You say we cannot reject the null. Don't say we accept the null. Again, I'm insisting we never accept the null. These things are very easy to understand. What you should just know is that if you're using T statistic, in order for you to reject the null, it should be greater than. If you're using probability value, it should be less than, right? So with T statistic, it should be greater than. With probability value, it should be less than. Okay, if you have this idea, then I'm going to show you an example. So, guys, I want to estimate what's happening to my Microsoft. So again, I want to estimate this model. Let me copy this model. Well, this model, I want to estimate this model. In GDP, so let's put here beta 0, beta 1 plus U. So I want to estimate this model. That is the effect of FDI on GDP. And here on Excel, I have my data, I have GDP, and I have FDI, right? So I'm going to copy my data to eViews. These things you know. My time span is from 1990 to 2019. So I'm opening eViews, create work file, dated regular annual, 1990 to 2019. Data, GDP, FDI, right? So I'm copying my data now and pasting on eViews. I've showed you these things in previous videos. You know all of this. Guys, by the way, I'm fast because there's no time. If you don't understand, please go back and watch the video. Watch it as many times as possible. If you have problem, you can ask me. So I paste my data on eViews. I delete this. Now, look at my model. My model is log. That is lean on both sides, right? So I want to generate the logarithm of both GDP and FDI. So I'll write generate lean GDP equals to log GDP. Press enter. For FDI, I don't want to repeat the step, so I just change this GDP to FDI. And I come here. I change this GDP to FDI. Okay, they tell me log of non-positive number missing data. Why? Because we have negative values in our series, and I showed you how to take the log if you have negative values, right? So I just go back to Excel. I look at my FDI series. I look at the highest negative value. You see here is 0.91, 0.12. Let me look for all the negatives. Here's 0.1. So my highest negative, this is my highest negative value, 0.91. So if my highest negative value is 0.91, it means I can just use 1 to correct. So you find the highest negative value in your series, and then you use a positive value which is closer to it to offset it, right? So since my highest negative value here is 0.91, I'll come to eViews. I can use 1. So what I'll do is I'll come here, I'll add plus 1, and then outside I'll subtract it. So you add it inside and you subtract it back from outside. If I press enter, I now have my logarithm without losing any value. If I had taken it before without doing this correction, I would have lost those negative values. Why? Because if you know maths very well, you will know that the logarithm of a negative value does not exist. The logarithm of 0 does not exist. It is undefined. We can only take logarithm of positive numbers. So when you have negative numbers in your series and you're trying to take the logarithm, it is undefined. So the if use is telling you that if you do it, you will lose some values. So we try to offset it by doing what I've done, right? I've done this in previous videos. Understood? Okay. So I've gotten my logarithm for GDP and FDI. Now I want to estimate this equation. Of course, you see GDP is dependent variable and FDI is independent variable, right? So I'll just come to quick. I come here, estimate equation, and here I'm just writing my variables. Always start with dependent variable, GDP, of course, ln, because we are using the log, ln GDP. Give a space, write C. C stands for constant, right? Give a space and then write ln FDI. So what do you see? You just write dependent variable, you write constant, and then you write independent variable. That's all. Why are you doing that? Because if you look at your model, you have dependent variable, you have constant, and you have independent variable. So you just write it in if use. If use understands. So I've written the variables. Once I've written that, I don't change anything here. I just click OK. This is my regression results, right? Now, this is my regression results. I'm looking at my coefficients. Okay, guys, this is my constant. You see here is C, so this is my constant. And here this is ln FDI, this is the coefficient, right? So what is my constant? Negative 1.25. So I want to write my estimated equation. So I'll come here and put constant is negative 1.25. And what is my coefficient of ln FDI? It is negative 0.003, right? So I'll come here. My beta one will be negative 0.003. Since I've estimated my coefficients, I delete error term. I cannot interpret these coefficients. Now, I know that since everything is log, I can use percentage. So to interpret this, I will say 1% increase in FDI will cause GDP to decrease. It has to be decreased because here is negative. So it will cause GDP to decrease by 0.003% on average, right? And if I'm to interpret this constant, I will say without the effects of FDI, the average GDP will be negative 1.25%.
0.3%.
No.
When I convert it to percent, that means 0.3%.
No. When interpreting coefficients, you use the coefficients the way they are.
Okay.
You don't come and say because this is 0.03, so if you want to convert, no. It is the way it is, that is how you use it, right? That's even if it was not in percentage, even if we were not using log, even if we were using level and we have to use the units, you still use those units. There is a time when we have to multiply by 100 and there's a time when we have to divide by 100, but that's if we are using maybe log level or level log. I showed you that. But if you are using log, you use a coefficient the way it is. You don't convert anything. If you don't understand, go back and watch previous video. Okay, guys, so this is our model. We have estimated the constant and the slope coefficient, and we have interpreted it. But were we supposed to interpret it? That's the question. Again, what you should know is that we don't interpret insignificant coefficients. So before doing this interpretation that we have done, we have to first of all check if these coefficients, the constant and this beta coefficient, are significant. If it is significant, then we can do this interpretation. But if it is not significant, then we cannot interpret because we never interpret insignificant coefficients, right? So let's check if the coefficients are significant. Now, I'm coming back to our t-test. This is decision criteria. So the first thing I'm going to use T statistic. Okay, let's go to e-views. You see here we have T statistics, right? Are you seeing T statistic? Here we have T statistic and we have probability value. We can use either of them or both of them. By the way, guys, just for your information, how do you calculate T statistic? It is coefficient divided by standard error. When you take any coefficient divided by its standard error, it gives you the T ratio or the T statistic. You can try it. So guys, look at this T statistic for this constant. Negative 29. It is greater than 2 in absolute value, right? Absolute value simply means if there is a negative, you should remove it. So this is negative 29. What's the absolute value? 29, right? 29 is greater than 2, right? So therefore, we can reject the null. Let me come back and show you something. Look at the decision criteria. If the absolute value of the T statistic is greater than 2, then we should reject the null. This 29 is greater than 2, therefore we should reject the null. What is the null? The null tells you that the coefficient is statistically equal to 0. So if we are rejecting this null, it means we are accepting the alternative. So we are accepting the alternative that the coefficient is statistically different from 0. Therefore, the coefficient is statistically significant. Because if it is statistically equal to 0, it means it is insignificant. But if it is statistically different from 0, it means it is significant. So since our 29 is greater than 2, we reject the null, and we accept the fact that it is statistically different from 0, therefore it is statistically significant. So we can interpret that constant, right? So this our interpretation of the constant is good. We can do it. Let's check now for the slope coefficient. Look at the slope coefficient. Look at the T statistic. It is minus 0.06. What's the absolute value? Absolute value is 0.06. Absolute value means that if there is a negative sign, just remove the negative sign. If it is positive, fine. But if it is negative, consider it without the negative. So here it is 0.06. Is 0.06 greater than 2? No. It is less than 2, right? Which means we cannot reject the null. Come back here and see decision criteria. If it is greater than 2, we reject. But if it is not greater than 2, then we cannot reject, right? So since that 0.06 is not greater than 2, therefore we cannot reject the null. So we cannot reject this null, which means we cannot reject the fact that the coefficient is statistically equal to 0. What is the null? The null says the coefficient is statistically equal to 0. If we cannot reject this null, it means we cannot reject the fact that it is statistically equal to 0. Therefore, it is statistically insignificant, right? And since it is insignificant, we cannot interpret it. Therefore, this interpretation, we're supposed to interpret the constant. This one is not supposed to be any interpretation. So therefore, this interpretation that I've done here, I was not supposed to do it, right? Because we don't interpret insignificant results. So you cannot come here and say a 1% increase in FDI will cause GDP to decrease. You don't do that. Why? Because the coefficient is not significant. So instead, what you write here is that, so instead of doing the interpretation, what you write here is that lean FDI has no statistically significant impact on lean GDP. Simple. If the coefficient is insignificant, you cannot interpret it. You just say that this coefficient has no statistically significant impact on dependent variable. We only interpret significant coefficients, right? So you have seen how we have made that decision using T statistic. Now we can also make this decision using probability value, and we will still have the same results. Let's make the decision using probability value. By the way, guys, I will take 5 minutes of your time. Instead of 220, I will leave at 225 because I want to finish this. Okay, so let's make this decision using probability value, and you should see. Now, if we are using probability value, then we have our levels of significance. For probability value, the probability value should be less than significance level for us to reject the null, right? Okay, I'm going back to e-views. Look at probability value. Look at for the constant, what's the probability value? 0, right? So 0 is less than 1%. So even at 1% level, we can reject. 0 is less than 5. So even at 5%, we can reject. 0 is less than 10. So even at 10, we can reject. So either any of the significance levels you use, you can reject the null. What is the null? The null says the coefficient is statistically equal to 0. So if you reject this null, you therefore accept the alternative which says it is statistically different from 0, right? Therefore, it is significant. So you discover that even using probability value, we still conclude that the constant is significant, and we make this interpretation. We only interpret significant coefficients. So let me write something here. Insignificant. Significant. So, guys, if the coefficient is statistically equal to 0, it means it is statistically insignificant. If the coefficient is statistically different from 0, it means it is statistically significant. So we have used probability value for constant, and you have seen that it is 0. So for any significance level we use here, 0 is less than 1, 0 is less than 5, 0 is less than 10. So even if you are using 10% or 1 or 5%, you can reject the null because the probability value is less than the significance level. So you can reject the null. And if you are rejecting this null, you are accepting the alternative, which says it is significant. So we can interpret the constant, right? Now let's look at the beta coefficient, that is the slope coefficient. Look at the probability value, 0.95. What is that? That is 95%. 95% is greater than 1%, it is greater than 5, it is greater than 10. So even if we are using 10%, which is like the lowest one we can accept, it is still greater than 10. Therefore, we cannot reject, because if probability value is greater than significance level, you cannot reject. So you discover that for the slope coefficient, we cannot reject the fact that it is insignificant. You cannot reject it. Therefore, we cannot interpret the slope coefficient. We just say that it has no statistically significant impact. But if it was significant, then we will do the interpretation by saying that 1% increase in FDI will cause this percent decrease in GDP on average. We can only do those interpretations if we have significant coefficients. If the coefficient is not significant, we don't interpret. So you discover that whether using probability, whether you are using T statistic or you're using probability value to make that decision, you will still have the same, you have the same answer, right? But in order to make, like if you are writing your project or in a test, to make it look more professional, more nice, you can use both of them. Like me, I always use both of them. What I will say is that T statistic in absolute value is greater than 2. Therefore, we can reject the null. Probability value is less than 5%. Therefore, at 5% level of significance, we can reject the null. Therefore, coefficient is statistically significant. Therefore, 1% increase in this will cause this percent decrease in this on average. Right? It's confusing, right? But it's good. It's fine. Sorry? No. I'm just showing you 3 of them, but we mostly use 5%. So most of the times, except in the exam, maybe Nigauja says use 1% or says, but I can assure you she will say use 5%. Everybody likes using 5%. But in statistics, at times we can use 1%, we can use 10%, but we mostly use, in the exam they will not tell you use all three. They will tell you use 5%. Yes, in the exam they will tell you use 5%. So if they tell you that use 5%, then you should make sure that your probability value is less than 5%. If it is less than 5%, then you should reject the null. But if it is greater than 5%, you don't care if. Yeah, you can use all three, but most of the times we use 5% because it is the generally used significance level. But like for instance, you can have a probability value like this 0.08. You discover that 0.08 is greater than 5, but it is less than 10. So if you are using 5%, it means you cannot reject. But if you're using 10%, it means you can reject, right? So it depends on you who is carrying out the research. What do you want to use? Then most of the times people use 5%. So I think we have 5 more minutes. Everything fine? By the way, if you don't understand anything, you can ask me. Okay. So you have seen how to interpret coefficients, you have seen t-statistic, you have seen probability value. Guys, the other thing I need to tell you is R squared, adjusted R squared, all these guys down here, but I cannot find time to tell you. I will just mention it now, but next class I will say more about it. What is this R squared? This R squared shows you the I will not write it out. I'm mentioning it, so if you listen to the video, you can write it down. This R squared is actually the coefficient of determination. It shows you the explanatory power of your model. What do I mean by that? Look at this is our model. What's our model? Our model is trying to find out the impact of FDI on GDP, right? So it means we are trying to see if the variation in FDI can be used to explain the variation in GDP, right? So we are trying to see if FDI can explain what is happening to GDP. Now, R squared tells us the explanatory power of your model. So if your R squared is greater than 50%, it is good. If it is really high, maybe 80-90%, it means your model has a high explanatory power. But if your R squared is less than 50%, it means your model has a low explanatory power. So you discover that here our R squared is almost 0%, 0.0. So our model has almost no explanatory power, which means FDI alone is not sufficient to explain what is happening in GDP, right? We need to add other independent variables. So we have something like omitted variable bias. I don't want to get into that, but R squared shows you the explanatory power of your model. Adjusted R squared is the same as R squared, but it shows you like what you discover is that the more you add independent variables to your model, your R squared goes up, right? So it will look as if your model has a high explanatory power, but is it true? Adjusted R squared will tell us that. So adjusted R squared is like the punishment. It's like it punishes you for adding more variables to the model, because you can be carrying out a research and you discover that your R squared is very low, and because you want to have a high R squared, you go and bring in more variables and add to the model, even though these variables are useless variables. Of course, your R squared will go up, but if these variables are not very useful, then it will be indicated by adjusted R squared. You will have a big difference between the R squared and the adjusted R squared. So if there is a big difference between the R squared and the adjusted R squared, it means that most of your independent variables are useless. They don't explain the dependent variable. But if the adjusted R squared and the R squared are close to each other, it means most of your variables are useful in explaining the variation in the dependent variable, right? All these other things, F statistic, Akaike criterion, Hanan Quinn, Devin Watson, I will mention them next week, and then we'll do something else. But for today, at least, I've showed you how to perform t-tests. T-tests using t-statistic or using probability value. One last thing I'll mention before you go is the difference between t-test and f-test. Now, t-test or t-statistic shows you the statistical significance of individual variables. But f-statistic shows you the statistical significance of all your variables combined. So in this case, since we have just one variable because it is simple regression, f-statistic is not too important. But when we'll be doing multiple regression, when we have more independent variables, f-statistic will be important because we need to check, because maybe you can find out that some of the variables are individually insignificant, but when you combine them as a whole, they might be significant, right? So we'll see more of that subsequently. Okay, let me let you go. See you. Watch the video. If you don't understand, ask me. Sorry? No, I will stop because I'm going somewhere. Okay, guys, see you. Bye bye.